Good morning.
Good morning, sir.
So you can hear me and you can see me, can you?
I can hear you and see you very well.
Well, that's a good start. You're talking to a small and select audience here in Old Bpl in central London, and a rather larger audience online. In a moment or two, Mr. Hill will start asking you questions, but first, Mary will invite you to take the oath. You are at home, I think, are you?
I'm in a room on my own in my house, yes.
And I think your wife and your son may be at home with you.
They are, but in a separate part of the house.
And there's no one else there at the moment.
No.
If we have any problems with the transmission, we'll sort that out as we go along, but I doubt we will have any. The only other thing to say is that if you want a break at any time, for any reason, just ask, and of course, you can have it.
Thank you, sir.
But if we do have a break, what you mustn't do is talk to anyone about the evidence you've been giving or any evidence that you may yet give, and that applies to any break at all. Okay?
Understood.
Right, Mary.
Please state your full name.
Terence Joseph Snape.
And repeat after me. I do solemnly, sincerely,
I do solemnly and sincerely
and truly declare and affirm
and truly declare and affirm
that the evidence I shall give
that the evidence I shall give
shall be the truth,
shall be the truth,
the whole truth,
the whole truth,
and nothing but the truth.
and nothing but the truth.
Dr. Snape, I'm going to begin just by asking you a few questions about the role that you undertook at PFL and at BPL, and then after that we're going to look at a video. But just by way of introduction, is it right that you have an undergraduate degree in chemistry from the University of Oxford and a doctorate from the University of London?
Both are correct.
And you worked at BPL, the Blood Products Laboratory at Elstree, and at PFL, the Protein Fractionation Laboratory at Oxford, from 1970 until 2000. Is that right?
That's correct. It's actually plasma fractionation laboratory, not protein.
I realised as I said it, I'd gone for the wrong P. You were initially at the PFL in Oxford, and you rose to become the head of laboratory after the retirement of Dr. Ethanol Precipitation. Is that right?
That's correct.
And then from February 1982, you were based at the Blood Products Laboratory, initially as head of quality control. Is that right?
That's correct, but during that time, I spent at least one, sometimes 2 days a week, still in Oxford at PFL, so it was a joint responsibility.
From 1988 until 1991, you were the the therapeutics manager at BPL. Is that correct?
That's the title I was assigned.
And then from 1991 until 2000, you were the technical director. Again, is that correct?
That's correct.
You took early retirement in 2000, and after that you worked as an independent consultant. Did that include some contracts of supply to BPL and the National Blood Transfusion Service and the Department of Health?
It did. They were yes, your words are correct.
But that was part of your wider role as an independent consultant from 2000 onwards.
It was indeed.
I'm going to come back to some of those roles in due course, but for reasons of logistics, we're going to look first at a video that you have helpfully provided to the inquiry. It is a video that shows BPL after it had been redeveloped in the 1980s. Is that right?
That's correct.
Where did you get this video from?
I was part of the team that commissioned the video at the time. I didn't have the presence of mind to retain a copy myself, but when, with the opening of 2018, the opening of the inquiry, I approached a former colleague who had a VCR copy of the video.
Why was the video commissioned?
We knew that we were building a special factory. We believed that it would be possible to recover some of the costs involved in building and running that factory by taking in contract fractionation once we had commissioned the factory completely. The timing was such that it allowed us to, while the factory was still was blacked, is the term. In other words, areas have not been rendered sterile and fit for use. We were able to allow a team in with video cameras to put together pieces of the video.
With that explanation, I think we will turn now to the video. What I'm going to do is play sections of it with the sound, because there is a commentary. Then we're going to stop, and if you would like to make any observations about what we have just seen, then please do so, and I may ask you one or two questions. So there'll be about 7 or 8 clips of this video. Could we have the first clip, Sully, please? The BPL video.
The manufacture of safe and effective blood products from human starting materials in amounts adequate to meet national needs represents a very major challenge, a challenge which is being met by the Blood Products Laboratory at Elstree with their new fractionation centre commissioned in 1987 for the National Blood Transfusion Service. With floor space of over 22,500 square metres, the entire building is designed, constructed and operated to meet all the latest and most stringent requirements of good pharmaceutical manufacturing practice. Critical processing is contained on one purpose-designed floor, entirely supplied with Class 1 filtered air to guarantee product safety. Factor 8 and albumin are the 2 major products, along with 15 others supplied to the NHS. BPL receives 40,000 plasma donations each week from the voluntary blood donors of England and Wales. Before release by the regional blood transfusion centres, all donations are tested for HIV antibody and hepatitis B antigen, making this some of the safest source plasma in the world. Although plasma is traditionally collected from whole blood, we now see increasing collection by plasmapheresis methods, such as the Haemonetics PCS, which presents high-quality plasma in a form easily manageable for processing. All incoming plasma is checked against the regional transfusion centre's dispatch form and onto a computerized plasma stock inventory.
Dr. Snape, is it right there that we see the external frontage of the new BPL, the redeveloped BPL, and the arrival there of donations of plasma that were being provided by regional transfusion centres?
Sorry, I'm not sure what's happened, but I'm not hearing you as well now as I was before the video played.
I'll try again. Dr. Snape, can you hear me?
I can now.
What we just saw was the external frontage of the new BPL and the arrival of donations of plasma from regional transfusion centres. Is that correct?
That's correct.
And would that have been, that form of arrival with the boxes that we saw, fairly typical of the way in which plasma was received at the redeveloped BPL?
Yes, it was. We supplied a number of freezer trailers to the transfusion service so that we could receive deliveries in the same format.
We'll go on to the next section, please, of the video.
Plasma is then stored at -40 degrees centigrade for at least 3 months before processing. The plasma is then stored at -40 degrees centigrade for at least 3 health complications that could result in a valuable processed batch
Sorry,
being
if we could
found
just stop
unfit
for
for
a second.
use.
There seems to be
There's a glitch somewhere.
a problem.
The plasma is then stored at -40 degrees centigrade for at least 3 months before processing. This eliminates any problem resulting from late reporting of donor health complications that could result in a valuable processed batch being found unfit for use.
Just pausing there, then. This is a shot, is it, of the area in which plasma was quarantined before being processed? Is that right?
That's the -40 cold room in which the plasma was quarantined, yes.
We heard on the commentary that I think it was said that it was about a 3-month period. We'll return to that, but is that about right for that period of time?
At that time, yes.
If we could, sorry, just so that we are clear, the plasma has come into the plant, it is being kept at -40 degrees for 3 months, and then what we will see next is how it is processed after those 3 months. Is that correct?
That's correct. What you're looking at on the screen at the moment, the pallets, obviously the plasma hasn't been unwrapped at that stage, and it wouldn't be unwrapped or a pallet wouldn't be entered unless there was a report compromising a particular donation that had to be removed.
If we could play on then, please, Sully, to the next clip.
The most efficient use of the valuable plasma starting material requires initial processing for factor 8. Each batch of factor 8 is made from some 13,000 donations, weighing approximately 3 tons in total. Frozen single donation plasma packs are passed through a purpose-built opening line. Individual donations are cut open and the frozen plasma expelled into trays in an adjoining room to provide the stripped plasma with maximum environmental security. The plasma is then placed onto racks for conditioning overnight at -15 degrees centigrade.
We have just seen a number of plasma bags being placed into a machine. Those are the single plasma packs, is that right?
Yes, often called IPPs, International Plasma Packs. It was a specific wedge-shaped pack made out of a specific polyolefin plastic, which limited the adhesion of the plasma to the pack. And so the wedge shape allowed the pack to be, once the top was cut open through the airspace in the pack, it allowed the wedge of plasma to be squeezed out and ejected, and that's what you saw.
That was being done by an automated machine, wasn't it?
It was.
And we heard last week something of the evidence about the introduction of single plasma packs and the commissioning of the tear-down machine, I think it was called, at Bpl. Is that what we have just seen in action there?
That's what you were watching in action there.
If we could go on to the next clip, please.
The first part of the factor 8 process is controlled thawing of the plasma. Bpl's purpose-built equipment has a throughput of 3,000 donations per hour. The frozen plasma is crushed and then fed into an attached thawing vessel where it is carefully heated and stirred to reach a temperature of -0.5 degrees centigrade. As the plasma thaws, some of the proteins remain insoluble. This is called cryoprecipitate and is rich in factor VIII. The remaining liquid, called cryosupernatant, is available for other processing. The output from the thawing machine, a mixture of cryoprecipitate and cryosupernatant, is piped to an adjacent room where the cryoprecipitate is separated out using two Westphalia BK28 continuous flow centrifuges. The highest possible precision control over flow rates and temperatures are essential at this stage to maintain process efficiency. The Westphalia centrifuge bowls are emptied under Laminar Airflow protection. This is cryoprecipitate. It must be as dry and free from supernatant as possible.
More down there. Okay, take it away, please. See which one's on.
By this stage in the process, the factor VIII present in the original 3 tons of plasma donations has been concentrated into a cryoprecipitate fraction weighing some 30 kilograms. Already, an increase in concentration of approximately 1,000-fold has been achieved.
The steps that we saw there, Dr. Snape, are the removal of the plasma from its storage overnight at -15 degrees into a process where it is warmed to -0.5 degrees, and then the separation of the supernatant from the cryoprecipitate through the use of centrifuges. Is that right?
With a slight modification in the sense that the cold room temperature was raised progressively so that the plasma, when the bags were opened, the plasma was very close to -1, -2 degrees, so that the thawing could be done in a more controlled fashion.
That is the temperature of the room in which the plasma was stored overnight, is that right?
Yes, that's correct.
That presumably would have been done by an automated process.
It was done by an automated process and it worked relatively well for the first year until we had a fire in the room when the heaters went out of control. But we were able to restore operations fairly quickly.
A phrase that was used in the commentary there was laminar airflow. Could you just explain to us what laminar airflow was?
Surely. Laminar airflow is literally a flow of air, filtered air, and that's critical, filtered through high efficiency particulate air filters, and the air travels in straight lines, and the result is to protect what's underneath or in front of the laminar airflow from contamination typically from operators who, although properly gowned, will still be shedding particles and therefore microorganisms.
Up until this point in the process, how does the new BPL that we are seeing in the video differ from the old BPL that we heard about in evidence last week? We'll see a video shortly showing a bit of the old BPL, but just in terms of a process, what similarities and differences are there?
The process in detail, if you sketched it out, would look the same. But the difference is the environment in which it was being performed, so that laminar airflow protection gave additional benefit to rooms that already were being served with filtered air. In the old BPL, there were very few rooms with filtered air. We had opening windows, and the environment was much a much less controlled environment, and the equipment was obviously smaller scale equipment, and not very attractive working conditions at all.
We'll go on to the next section of the video, please, Sully.
The cryoprecipitate is transferred to an adjacent room, where it is redissolved in a tris buffer in a closed stainless steel vessel. Purification is achieved by a series of steps resulting in the precipitation of unwanted proteins, which are then removed in batch-type MSE centrifuges. Bpl uses 6 of these centrifuges, each capable of handling up to 6 litres. After centrifugation, the supernatant which contains the valuable factor 8 is recovered and the precipitate discarded. Further purification is achieved by glycine precipitation of the factor 8 from solution. This precipitate is then recovered on 4 Padberg continuous flow centrifuges. By this time, unwanted proteins, such as fibrinectin, which would prejudice later viral inactivation steps, have been reduced to a minimum. At this stage, the factor 8 from 13,000 donations of starting plasma has been reduced to a mere 900 grams. Great care is taken to remove every last trace of the precipitate from the centrifuge liner. The precipitate is now redissolved in another buffer solution. Unwanted salts are removed by passage through a gel filtration column. A bacterial retentive Paul filter is used to sterilize the 20 litres of factor 8 solution, after which the solution leaves the class 2 processing area.
Dr. Snape, is it fair to summarise what we have just seen as a series of steps designed to purify the factor 8 that is going to be used in the concentrates that are produced at Bpl?
That's correct.
Again, the same question as I asked you before. What were the differences here between the new Bpl, and as I understand it, this was aimed at producing the product 8Y that we heard about last week. What were the differences between there and the old Bpl, both in terms of process and facilities?
I'll just qualify, if I may, what you've just said. The new BPL factory, Building 27, was not targeting. 8Y was simply a dream at that stage, not a reality. But the process that transferred eventually from the old facility into the new Building 27 was 8Y. The steps were essentially the same as those performed in the old BPL. but in the old BPL under much, much less controlled conditions and on a much smaller scale.
In terms of previous products that have been produced at BPL, I'm thinking in particular of 8HL, the intermediate purity factor concentrate. Would that have gone through the same stages of purification as we have just seen in the video?
Some of them. The final precipitation to remove fibronectin and fibrinogen was less efficient. There was more contamination with those sticky proteins in the HL product or the HCRB product that was manufactured at PFL. 8Y was significantly higher specific activity.
We'll come back to some of those terms in a second. I just want to ask you about the phrase Class 2 room that was used in the video. What does that mean, please?
It was the classification of air quality that was in use in the mid-80s. We would now use different terms, but Class 2 was a background in which it was a room supplied with filtered air through high efficiency particulate air filters. And Class 2 described the acceptable level of particulate contamination in that room that was monitored by environmental monitoring techniques. Passing through, we saw the product being filtered and that removed bacteria present in the solution. And then the tubing passed through the wall into a Class 1 environment where the filling operation would happen. Those terms haven't been used for the last 20 years. We now have a series of grades of air that serve the same purpose, but 4 steps rather than the 2 that we heard referred to there.
Is Class 1 an area which is more sterile than Class 2?
It is. Sorry, I'm going to be picky, okay?
Please do.
You can't be more sterile.
Yes.
It's either sterile or it's not. Class 1 has fewer particles in the air than Class 2.
Thank you for the correction.
That's okay.
Was there any equivalent of a Class 1 and a Class 2 room in the old BPL?
They existed. Whether they were the environmental monitoring that was performed was not as good as we would have liked, and that improvement was important in switch to Building 27 from Building 25.
Building 25 was the old BPL, just so we have our terminology.
That's right, yes.
We've heard on the video that we started off with the opening shot of the plasma coming in with 13,000 donations and about 3 tons of plasma. That was reduced down to 30 kilograms of cryoprecipitate and then 900 grams of factor 8, which was to be redissolved in a solution. Is that a correct summary?
Yes, as long as you don't assume that factor 8, that 900 grams, still had other proteins than factor 8. And those proteins were quite important to stabilize the factor 8. You can only increase purity so much before a protein like factor 8 becomes very labile, very easy to destroy.
If we could return, please, to the video.
Environmental monitoring procedures are carried out at all critical stages of the fractionation, purification and filling processes. Now, the sterile solution is piped into the Class 1 sterile suite, where it is collected in a sterile reservoir. The sterile solution is transferred to a Bausch & Strobel aseptic filling machine, where 10 milliliter doses, each containing 250 units of factor VIII, are accurately dispensed into sterile vials. The vials are then partially closed. Both of these critical operations take place under laminar airflow protection. The vials are now carefully transferred to one of a bank of Edwards freeze-drying chambers located within the sterile suite. It takes up to 4 days to remove all of the water and arrive at a stable, dried product. The use of a computer-controlled system ensures consistent primary and secondary drying characteristics from batch to batch. At the end of the drying process, the stoppers are automatically fully inserted into the vials before the chamber is opened and unloaded.
Could you just explain to us, Dr. Snape, the importance of the precision in the freeze-drying process that we just heard about in the video?
Yes. In simple terms, it was the control of freeze-drying, the precision of control of freeze-drying that allowed us to make the progression to severe dry heat treatment. And it was important that that precision was maintained from batch to batch. It would be possible to carry out that process in that freeze-drying process in other ways and to obtain a product that looked and biochemically might be similar, but unless the moisture content was controlled and the microcrystalline structure of the frozen factor VIII was properly maintained, it's unlikely that it would be possible to perform the same extreme degree of heat treatment successfully from batch to batch.
The degree of heat treatment that you're talking about, is that 80 degrees for 72 hours?
That's correct.
Again, we'll come back to that heat treatment in due course. The same question as before, could you just explain any differences in process and in equipment between the new and the old BPL in that section that we have just seen?
Yes, starting with the filtration operation, the filtration would have looked physically the same, but you saw an operator there carrying out what would classically be called aseptic technique to make connections between two tubes, one on the grade 2 in the grade 2 environment, one in the grade 1, and the degree of protection there would have been much lower in the old BPL, and environmental monitoring results would have shown that. The automated filling, the three-headed filling machine, Bausch & Strobel filling machine, the filling machine in the old BPL would not have been protected with the same degree of laminar airflow protection, and the filling operation would have been essentially manual rather than automated as you saw it. Freeze drying, the freeze dryer was much older, not as easy to control until we switched to the same Edwards freeze dry system in the old plant, but a single dryer rather than the bank of freeze dryers that you saw, significantly limited throughput. And operators would not have been moving in the same class 1 air that they're moving, that you saw them moving there in the video clip in Building 27.
If we could go on, please, Sally, to the next part of the video.
The closed vials are now oversealed with colour-coded caps. This not only helps to maintain the vacuum in the vial, thus preventing the ingress of moisture, but also provides tamper-proof security. Before the batch can leave the sterile suite, it is put into security cages. At this stage, and at every other stage in the process, the number of vials are checked and cross-checked. Finally, the security cages are fastened with numbered seals, and the batch of factor 8 is transferred for viral inactivation. Each batch is heated at 80 degrees centigrade for 72 hours in a precision-controlled hot air oven. Factor 8 Type 8Y, manufactured at BPL, is the only product of its kind in the world sufficiently pure and stable to successfully withstand this dry heat treatment process, which is more rigorous than any other currently in use. After heat treatment, quality control testing and inspection, the batch is labelled and packed. Here again, a purpose-modified semi-automated line is used. Cartons are packed with an instruction leaflet, a vial of factor 8 and one of sterile water for injection, and a needle for use on reconstitution. A random inspection of the product by quality control staff occurs before cartons are packed. Factor 8 is distributed to regional transfusion centres and haemophilia centres throughout England and Wales. Every issue is recorded to enable full batch reconciliation and traceability.
Dr. Snape, what we have just seen is the process from the sealing of the factor 8 concentrate in its bottle, its heating, then the labelling process, the quality control process, and the dispatch. Again, the question of how that differed in terms of process and equipment between the old BPL and the new BPL, please.
In the old BPL, obviously we commissioned, I believe, 2 of the dry heat treatment ovens, but in a much more rudimentary background, and the external environment was simply less controlled. It's worth making the point that what you saw right at the beginning of that clip with the blue overseal caps dropping in and being used to overseal the factor 8. Regulatory requirements move on continuously in a process like this, and now that would be that being performed in an open environment with operators gowned, as you saw, it simply would be unacceptable. That would also be under laminar airflow protection, because it's assumed that until that overseal is placed on the vial, the product isn't secure. But that's just a case of keeping pace with appreciation of regulatory requirements. The inspection, labeling and packing, you would have seen the same thing, but in a much less attractive environment.
Is it right then that there are three main differences between the old BPL and the new BPL, if I may simplify it slightly? The first is that there were far greater environmental controls at Building 27 when compared to Building 25, which presumably led to a safer environment in which to produce the product. The second was that the size of B27 was much bigger than B25, and the size of the equipment was bigger, allowing a greater throughput. And thirdly, the use of those bigger machines and greater automation meant that processes could be done at greater speed and greater volume than they have been at B25. Is that a fair summary?
That's a reasonable summary. I think I would add one thing to that for me made all the difference, which is that the quality of air supply to the rooms in Building 27 was significantly higher. The rooms, none of the rooms have opening windows. The air supply is filtered air supplied to every room to a degree of filtration appropriate to the activities happening there. In Building 25, that simply wasn't the case. A window was opened, and if a fly flew in through that window, well, it was there.
In order to get an idea of what is required to provide that degree of airflow to the rooms, perhaps we could go, please, Sully, to clip 9. We finished the process for factor 8. This clip shows the, as it were, the engine room of the new BPL and some of the the machinery that was required to supply it.
So far, we have seen the ultra-clean processing operations. But in order to enable a high-technology manufacturing unit like BPL to operate effectively, So far, we have seen the ultra-clean processing operations. But in order to enable a high-technology manufacturing unit like BPL to operate effectively, considerable care and attention must also be paid to the support services and facilities. For example, 16 air handling units are needed to provide at least 20 changes of filtered air per hour throughout the process areas. 9 major compressor sets generate the refrigeration required for the cold rooms, the process cooling, and the air conditioning. 2,800 kilograms per hour of demineralized water is heated to produce clean steam, vital to the autoclaves and the process sterilization systems. Demineralized water is also needed in the production of pyrogen-free water, which is produced at a rate of 7.2 cubic meters an hour. Town's water, a vital ingredient in the successful functioning of the whole manufacturing process, is supplied at the rate of 750 cubic meters a day, with a reserve tank capacity for at least 1 day in the event of a supply failure. A purpose-built plant to recover ethanol from the waste supernatants has been installed. It is designed to recover 40,000 litres per week, at a purity which will enable it to be reused in the fractionation, providing considerable cost savings. This complete state-of-the-art manufacturing unit enables BPL to meet the challenge of providing sufficient quantities of high-quality blood products to fulfill the needs of the United Kingdom.
We could stop there, please, Sully. What we have just seen to a layperson looks like an industrial scale plant. Is that a fair description?
Yes, we still called it at that time Blood Products Laboratory, but it simply wasn't a laboratory, it was a factory. And we saw there most of the engineering that was indoors is in the ground floor of that plant. The process floor above that is where the clean processing took place. But above that is a third floor, and that third floor contains an awful lot more in the way of the heating and ventilation, air conditioning, feeding ducts to every room in the process floor. I'm not sure why we didn't include that in the video. It a little boring, perhaps. The other thing about scale, the comment about water, my rule of thumb typically was that for every ton of plasma that we were going to process in a year, we would use a ton of town's water per day to achieve that. So for a plant processing 600 tons of plasma a year, we would use 600 tons of town's water per day. We would convert half of that into purified water, and we'd convert probably 2/3 of that purified water into distilled water. So the water was a significant underpinning of the whole process.
We heard over the last couple of weeks the importance that Dr. Lane placed on the physical site of BPL in order for it to be redeveloped. The old site, before it was owned by the Department of Health on behalf of BPL, was, in his view, simply not big enough to allow for the kind of redevelopment that we've just seen. Would you agree with that?
Absolutely. The building 25, the old building, was tiny, and it was serviced quite inadequately, both in terms of water, purified water, the refrigeration, and the heating, ventilation, air conditioning. Much more rudimentary.
The video goes on, I'm not going to show it now, but it goes on to show the production of albumin and the processes involved there. And as we saw at the end of the video, there was a list of, I think, 15 other products that BPL produced as well. It's important to remember, isn't it, that it's not just Factor 8 that was being produced at the site?
You're quite right. It's not just Factor 8 that's being produced. It's also not just Factor 8 that had to transfer from the old facility, Building 25, to the new facility, Building 27. Each of those processes had to be transferred, and sometimes we were not able, we had to take advantage of the scale in Building 27 and the improved environmental standards to upgrade the equipment that we used. So the centrifuges used to recover cryoprecipitate and to recover other parts, the fraction 5 for albumin, the fraction 2 for immunoglobulin, those centrifuges were different. And every one of those processes had to be transferred and qualified in the new Building 27. So not one process, but 15 processes.
If we could turn now to some clips that we have of Building 25, the old BPL. These come from the World in Action documentary, The Blood Business, which was broadcast in 1980 and made by Granada Television. There are a series of short clips. I'm not going to ask for the commentary to be played. The inquiry has seen this video in full and seen the comments made by the journalists and indeed by the interviewees, including several politicians. The reason for playing them now is just to show something of a contrast between the old BPL and the new BPL. For each clip, I'll ask you to describe what it is that we are looking at. There is one clip in particular where the documentary shows some graphics quoting the words of the Medicines Inspectorate report, which appear on screen. I'm afraid we can't remove those, so we will just have to look through them to the scene that is behind, and we'll come back to the Medicines Inspectorate report in due course. But if we could play, please, without sound, the first of the clips from MDIA 40109. We could just pause there, please, Sully. What did we see there, Dr. Snape?
The first thing that you saw was a cold room, a room in which Sharple's, that was the brand of centrifuge, Sharple's centrifuge bowls were being removed from the Sharple's and probably containing either cryoprecipitate or more likely fraction 2 or fraction 5, and they would be opened for recovery. What you then saw, what you didn't see properly, was looking up. If you could have looked up at the ceiling, you would have seen a ceiling composed of panels that were not sealed. You would have seen maybe cobwebs or something similar that couldn't be removed. You'd have seen mold in that background. You then saw the top of a tank room in which the operator switched on a light and looked down into probably 2,500 litre vessel, and you could see something mixing there, probably fraction 2 precipitation happening there. You would not have had the HEPA filtered air supply to that environment, but it was functional, but well beyond its use by date.
If we could move on, please, Sully, to the, I don't think we need to show the second, but the third of the clips from 7:35, please. Thank you, Sully. Dr. Snape, what were we looking at there in between shots of the Medicines Inspectorate report?
First of all, if you look down in that cold room, you would have seen quarry tiled floors with grouting between the tiles, very difficult to keep clean, and grouting breaks up under those conditions. If you looked up, you would have seen a ceiling completely unsuitable for the purpose, no air ventilation, no filtered air ventilation to that room, very limited air ventilation, and often mold growth. And then you saw a lovely example of overcrowding in that situation, with too much happening, pipes on the floor that shouldn't be on the floor, but very difficult to do anything about it. All of the list of criticisms from the inspector's report that were overlaid onto the screen, I would have to agree with every single one of them. It was, we had to work very, very hard to produce satisfactory quality product in that building.
Just so that we have it on the transcript, I should say the timings there were 7 minutes 35 to 8 minutes 47 seconds for that clip. And the first clip was 1 minute 14 to 1 minute 42 seconds. If we could go to the next clip, please, which is from 16 minutes and 44 seconds to 17 minutes and 5 seconds. We just pause there, Sully. Am I right in thinking that that is a 5-litre plasma pack, the old style of plasma pack, and it was being cut open manually? Is that a fair summary?
Absolutely. That pack, called a Valet pack after Mr. Valet, would have contained probably 25 plasma donations. They might have been recovered plasma donations. They might have been fresh frozen or fresh frozen plasma donations. But yes, 25 donations. It had been softened by laying those packs on in trolleys in probably a -5 cold room to soften overnight. And then you saw them being manually opened. Very unattractive procedure carried out in a very unattractive environment.
Even before that plasma had reached BPL, as you say, it would have been pooled at the regional transfusion centres. Is that right?
Yes.
The conditions under which it was pooled at the regional transfusion centres would vary centre from centre, presumably. Is that fair?
Yes, just in the same way that the conditions under which the blood donations from which the plasma was derived would vary depending on whether it was carried out in a village hall or a transfusion centre.
We heard in evidence, not last week, but the week before, about Dr. Lane's desire to change to single plasma packs. One of the reasons that he gave was that the pooling that took place at regional transfusion centres would be done in conditions that were not aseptic. And as a result, there was a risk of contamination to the plasma even before it had reached BPL. Is that a concern that you shared?
Absolutely.
The difference between that and the single plasma pack is that there would have been no open system for the plasma to be placed into the single plasma pack. Is that correct?
That's certainly true. It's not just environmental issues, though. It's not just, microbiological or avoidance of microbiological contamination is important, but it was also easier to manage a credible process using the single plasma pack. It was always going to be possible to automate the single pack process in a way that simply couldn't have happened with the 5-litre packs.
As we saw in the video, there is a technician literally cutting the 5-litre pack open with a pair of scissors. Is that right?
And hopefully not cutting himself, yes.
If we could go on, please, to the next clip, the 5th clip, which is at 1931 to 1947 of the video. Pause there. What are we looking at there, Dr. Snape? Sorry, not of the moment, but what were we looking at in that clip?
You were seeing exactly the same operation that you saw in Building 27, the removal of cryoprecipitate from the PTFE centrifuge liner, but performed without the benefit of laminar airflow protection and without the benefit of the room conditions that made such a difference in Building 27.
If we could go finally to the last clip from 24 minutes 53 seconds to 25 minutes 25 seconds, please, Sully. 7. Again, Dr. Snape, if I could ask you just to describe what we have just seen, please.
Essentially the same operation, though I think what you got an even better view of in that clip was the ceiling above the operator where the operation was being carried out, with a plethora of fluorescent tubes, cabling, and things that made cleaning in that kind of environment also almost impossible.
Thank you very much. We'll leave the videos there so that it is on the transcript. The first video that we saw, the one that has been helpfully provided by Dr. Snape, has the reference WITN 3431003. Could we have on screen, please, Sully, WITN 3431011, please? Sorry, WITN 3431011. Can I check, Dr. Snape, that you can see this document on your screen?
I can see it. It would be nice if I presume it can't be enlarged. Oh, wait a minute. I think I can do it for myself. Oh, good. Excellent. Thank you.
Thank you, Sully. We can see at the top right-hand corner the words Terry Snape Consulting Limited 2019. So this is a document that you have put together. Is that right?
Yes, I put it together for a training course that I was delivering at the time. But it is not a facsimile, but a good representation of the process flow at BPL. in up to 2000.
Does that include BPL both before the move to B27 and after moving to B27?
Yes, it does.
It is
I mean,
entitled...
the number of plasma donations might differ, but essentially the same process.
The document is entitled BPL Plasma Fractionation Schematic. And if I can just describe it, we see a box at the top, which is the starting plasma pool. And as you say there, it is stated there to be less than 7,500 donations, but that may change over time. The first stage shown is the thawing of the plasma pool to allow for cryoprecipitate, and then the manufacture of factor 8. And that is what we've just seen on the video. Is that right?
That's correct.
The next stage is the cryoprecipitate supernatant is subject to chromatographic recovery of other clotting factors. And from there, factors 2, 9, and 10, as well as various other fractions are produced. Is that right?
That's correct. We would recover the three-factor factor 9 concentrate, 2, 9, 10, that we originally called 9D, but became 9A after heat treatment, but also antithrombin 3, factor 7, factor 11, factor 13. Factor 7, factor 11, factor 13, clotting factors used for other forms of bleeding disorder with maybe different characteristics from hemophilia A, factor 8 deficiency, or hemophilia B, factor 9 deficiency, but still very important clotting factors to those people who had that bleeding disorder.
Okay. May I just ask, this shows 5 fractions. Is fraction 1 cryoprecipitate? Or is fraction 1 the proper title for the production of factors 2, 9, and 10, etc.?
That's a very good question, sir. The fraction 1 was actually in the schematic originally developed by Kistler and Nishman, was a fibrinogen fraction that would have been used and also the source of Blombach factor 8, the first freeze-dried concentrate. Cryoprecipitate was the way of recovering, a much more efficient way of recovering factor 8 than having to precipitate fraction 1 with 8% ethanol. And so a significant distinction. And then the fractions as we proceed down, A plus 1 is a combination of the clotting factors, of the fractions that we made immunoglobulin from, but still some fraction 1 in there. Fraction 4, at the time that we're discussing in the inquiry, fraction 4 was not processed further by BPL. And then fraction 5, paste, the bottom fraction on the right-hand side, is the fraction we used for albumin.
So what happened to fraction 3?
Sorry?
What happened to fraction 3?
When I first started to work at PFL in 1970, fraction 3 was a fraction that was shipped over from BPL Elstree to PFL at Oxford. And for about 5 years, we recovered a 4-factor, factor 9 concentrate from that fraction 3. It contained prothrombin, factor 2, factor 9, factor 10, and factor 7. It was a difficult product. I learned more about making a roux from calcium phosphate, processing fraction 3 to the 4-factor clotting factor than I ever did in my mother's kitchen.
Thank you.
Just returning to the schematic, we can see the AI paste, the fraction 4 paste and the fraction 5 paste are all products that have been recovered using ethanol precipitation. Could you just describe to us what ethanol precipitation is, please?
Yes. It's an approach practiced slightly differently both in the US and in Europe, in which you progressively increase the alcohol concentration of a solution, at the same time reduce the temperature of the solution, because if you don't, you will damage the proteins that you're trying to recover. So the fraction 1 that was just referred to would have been at 8% alcohol, with NC ethanol precipitation at 19% alcohol to give the A+1 paste, and then a further increase in ethanol to 40%, temperature dropping initially to -5 and then to -7. And each of those steps allows us to precipitate and recover a different fraction. It's the fundamental basis of plasma fractionation as practiced from the 60s onwards. There are other ways of doing it, but ethanol worked well. When the Lister Institute started plasma fractionation on the site at Elstree, they didn't use ethanol, they used ether. And I thank the Lord that I didn't have to work in that environment with the ever-present risk of explosions from ether-laden air. But the facility survived.
Is it right that the overarching concept of this is that by taking these different steps, you can get as much from your plasma pool as is possible according to the technology at the time?
Yes, it was absolutely vital for economic fractionation to recover the maximum number of factors. The description that I often use to give people an idea is fractionation is almost like a milking stool with 3 legs. And the 3 legs are clotting factors, albumin, and immunoglobulin. Take away any one of those legs, and the plasma is being underused, and the process is uneconomic. The more you can recover at each stage, the more efficient is the use of the donor's gift of plasma.
Just before the break, there are 3 concepts that I would like to ask you just to describe briefly, if you can, as a basis for some of the questions that we're going to come to later. The first is potency. What does that mean to a fractionator?
Okay. The term potency is, it's not a term that a chemist would typically use. It's a term that's necessary because you can't weigh factor 8. You can't use an electronic tool to measure factor 8. you have to measure it by comparison in one sample in comparison with another, a test sample compared with a reference preparation. And the potency is the number of units of factor VIII, for example, present in a solution compared with normal plasma. And that term potency drives the whole of the clotting factor process.
The second term is purity. What does that mean in this context?
Okay. It's the term, I never liked it. Purity, a better term is specific activity. Purity is the number of units of whatever material you're measuring expressed as in relation to the total protein that's present in the sample that you're testing. So specific activity, units of, say, factor VIII per milligram of protein.
The final term is yield. Could you explain that in the context of fractionation, please?
Yes. And there are, yield is a measure perhaps for a whole process, but maybe also for an individual step of a process of how much of the target protein you're able to recover compared with how much was in the starting material. So if I use the old 8CRV or HL product, yield for that process would have been something like 20 to 25% of the factor VIII that was present in the starting plasma. There is another word that's important to think about when thinking about yield, and that's what's the yield that's available to the patient. And that's often called recovery. So how much of the factor VIII that is infused or injected into the patient can be recovered into the patient's circulation. But we wouldn't use the term yield for that, we'd use the term recovery.
Sir, I'm about to move on to a separate topic. I wonder if that might be an appropriate time for a break.
Yes, it would. Well, we'll take a break, and we'll come back at 10 to 12. 10 to 12, Dr. Snape.
Thank you.
10 to 12.
Thank you, sir.